talk about dividing complex numbers. In these examples, our goal is to rewrite our complex number as something of the form a plus bi. So I want to separate out the real term and the imaginary term. What I'm going to do here is focus on just rationalizing the denominator of each of these. So to do that, I'm really looking for an I squared in the denominator. Well, the first one, that's pretty easy to do. If I'm trying to get an I squared in the denominator, I'll just multiply both the numerator and the denominator by I. Then I have 3i over I squared. And I squared we've talked about is just -1. So this becomes 3i over -1. And I can divide the 3 and the -1 to get just -3i. So the real component of this one is 0, and that imaginary component is -3i. Now the second one is a little bit more complicated because we do have two terms in the denominator. We can't just multiply by I to get I squared, because what happens is when I multiply by I then have to distribute to the I and to the 4. So yeah, I get I squared, but then when I multiply to the 4, I get -4i, and we still have an I, so we're back to square one. So what we do instead is we multiply by what we call the conjugate. We've talked about the conjugate before. That is just the same two terms, but the imaginary component changes sign. So that would be -I minus 4 in the numerator and the denominator. Now in the denominator, we do end up with the difference of squares, but it might help if we rearrange those two. So I'm going to rewrite this as 7 times -4 minus I. I'm just rearranging that real component and the imaginary component. And in the denominator, I'm going to rewrite that as -4 plus I, and the other term is -4 minus I. So in the numerator, I distribute that 7, and that's not so bad. 7 times -4 is -28. 7 times -I is -7i. In the denominator, you might recognize the difference of squares. The difference of squares says if you have two perfect squares and you're subtracting them, then we just take the bases and we add them and we subtract them. And that will give you your factored form. So what we're doing is we're starting here and we're going to go backwards. So I have two bases, -4 and I, and those bases are repeated in the second factor. So I have the same two bases, and then I see that I'm adding those bases and I'm subtracting those bases. So I have the form of difference of squares. So now what I can do to multiply this out is just take the two bases, square them, and then find the difference. So my two bases are -4 and I'm going to square them and then take the difference. If you're not comfortable with that, you can go ahead and FOIL out or multiply out that denominator. From here, I keep my -28 minus 7i, and the denominator becomes 16 minus I squared is -1. I change that to 16 plus I, and I add to get -28 minus 7i over 17. Now to write this fully in the form that we were asked to write it in, I'm going to now split up my fraction. I have -28 and -7 both divided by 17, so I'm just going to write them as separately divided by 17. So my final answer will be -28 over 17 minus 7 over 17i. And this is in the a plus bi form that we were looking for. Okay, let's do one more. So we're going to do the same thing, but this one's got a little bit more going on because we have an imaginary term in the numerator now as well. I'm going to do the same thing I did in the last one and multiply by the conjugate, which is the same two terms, but the imaginary one, or the one with the radical, changes to the opposite sign. So for -3i. And again, that just creates the difference of squares for us. So in the denominator, I do have the difference of squares. I have the same two bases, a 4 and a 3i, and they are being added and subtracted. So to multiply them out, I can square them separately and then take the difference. Now, unfortunately, the top is not that straightforward. So the top, the numerator, I'm going to have to multiply out. I distribute my 5, and then my negative 2i, and I simplify. So this would be your expression in the form a plus bi. So those were a couple examples of dividing complex numbers. I hope that helped. Thanks so much for watching, and I'll see you next time. Bye.